All right, today we're jumping straight into the deep end. We're going to look at the architecture of a protocol that, and I'm not exaggerating, could be as fundamental to AI as HTTP is to the web. I'm talking about the agent-to-agent protocol, or A2A. If you are sick and tired of building brittle, one-off integrations for your AI agents, then you absolutely need to understand what A2A is trying to fix. Let's get into it.
Look, if you've ever tried to get two or more sophisticated agents to actually collaborate on something meaningful, you already know the pain. It's a total mess of bespoke, point-to-point integrations, security is often an ad hoc afterthought, and the engineering overhead just kills your velocity. Every single new connection is a ground-up project, and that, my friends, just does not scale.
So this slide really shows the massive shift A2A is aiming for. On the left, that's the reality for most of us right now. A tangled web of custom connections where we end up crippling these powerful agents by just treating them like simple API tools. But on the right, that's the A2A vision. A standardized, secure network where agents can actually collaborate as true autonomous peers.
So here's our game plan. First, we're going to really dig into that integration nightmare. Then, we'll introduce A2A as the solution, the lingua franca. After that, we'll do a deep dive into its core architecture. We'll also unpack what I think is its killer feature, extensibility, and see who's actually using it today. Then we'll wrap up by looking at the future, this vision of a web of agents. Okay, let's really frame this problem correctly. Think of the state of multi-agent systems today like the web before HTTP. Seriously, you had every server and every client speaking its own proprietary language. Building anything that worked across systems was a massive, bespoke engineering lift. Well, that's exactly where we are right now with AI agents.
And just to be crystal clear, these aren't just minor inconveniences. These are fundamental blockers to progress. You know, when we dumb down a powerful reasoning agent into a simple tool, we lose the very autonomy that makes it valuable in the first place. Every single connection is a potential security hole, and as you try to scale from 2 agents to 20, well, the complexity just explodes exponentially. From a pure engineering standpoint, it's completely unsustainable.
And that mess is what brings us to A2A. The proposed common language, the lingua franca for agents. Now, this thing started at Google, but it's since been donated to the Linux Foundation. And that's a really critical move, right? It ensures vendor-neutral governance and an open future for the standard, which is exactly what you want to see. So what is it, technically speaking? A2A is an open standard that lets agents, it doesn't matter who built them or what framework they're on, find each other, understand what they're capable of, negotiate how to work together, and then securely collaborate on tasks. You can think of it as the universal adapter for the age of agents. The design choices they made here are frankly really smart. Instead of trying to reinvent the wheel, it's built on standards we developers already know and use, HTTP, JSON, RPC. That drastically lowers the barrier to adoption. Security isn't an afterthought, it's baked in from day one. And it's designed for the reality of agentic systems, which means long-running asynchronous tasks. Oh, and opaque execution? That's a huge one for businesses. It means you can collaborate without exposing your proprietary logic.
Okay, time to get into the mechanics. Let's pop the hood. We're going to look at the 3 pillars of the A2A architecture. How agents describe themselves using these things called agent cards, how they manage work through tasks, and, of course, how security is handled.
Everything in A2A really kicks off with the agent card. The best way to think about it is like a machine-readable robots.txt or a business card for agents. It's a simple JSON file that acts as the cornerstone for discovery and interaction, and it lays out everything: the agent's endpoint, its capabilities, and its authentication requirements.
Let's just pause on this JSON for a second, because this right here is the core manifest. You can see the URL, that's the endpoint, easy enough. Under capabilities, it's advertising that it supports streaming via SSE. Now look at security schemes. This is critical. It's explicitly telling you, I require OAuth 2. And then skills lays out exactly what this agent can do. It's a completely self-describing contract that any other agent on the network can use.
So this flow shows how it all ties together in practice. First, a client agent discovers another agent's card. Then, based on the security schemes listed right there in the card, the client goes and gets the necessary credentials. This happens out of band, which just means it's a separate process, like a standard OAuth flow. Once it has a valid token, the client can initiate a task and start getting updates on its progress. Simple as that.
Now, the protocol's flexibility in handling these updates is what makes it so practical for different kinds of architectures. For simple stuff, yeah, you can use high-latency polling, but for real-time results, you can use server-sent events for a nice, low-latency stream. And for those really long jobs that might take hours or even days, the server can just use push notifications to a webhook. This kind of adaptability is absolutely key for enterprise adoption.
All right, now let's talk about what might just be the single most important part of A2A. It's extensibility. This is the feature that's designed to keep the protocol from becoming rigid and outdated. It allows all of us developers to innovate on top of the core standard without breaking it.
And this quote from the docs just nails the design philosophy. The whole goal is to allow for specialized, domain-specific features without fragmenting the core protocol. So anyone can innovate out on the edge, and then the best ideas can eventually get incorporated back into the main standard. It's a beautiful model. So how does it actually work? Well, it's pretty elegant. An agent just declares the extensions it supports right in its agent card. Then a client can activate an extension by simply including its unique URI in an HTTP header. And these extensions can be incredibly powerful. We're talking adding new data fields, entirely new RPC methods, or even modifying the task state machine itself. And because anyone can define and publish an extension, the ecosystem can innovate at a crazy fast pace.
And the SDKs make this super practical. Just take a look at this Python snippet. A developer created a custom timestamp extension. Now, why would they do that? Imagine you're trying to debug a ridiculously complex multi-agent workflow. This little extension could inject precise timestamps into every single request and response, making it trivial to trace a task across a distributed system. And all they have to do is add it to the agent capabilities, and boom, it's discoverable, it's available. That's how you solve real-world engineering problems without waiting for a standards committee to meet.
A protocol is only as good as its ecosystem, right? So let's switch gears from the technical specs to the real-world adoption. Who's actually backing A2A?
The momentum here is pretty significant. We're already seeing over 150 organizations actively contributing to and building on the A2A protocol. So this isn't some niche academic project. It has serious industry weight behind it.
And I mean, the list of partners really tells the whole story. You've got every major hyperscaler, AWS, Microsoft, Google, plus enterprise giants like Salesforce, SAP, and IBM. This level of cross-industry alignment on a brand new standard is incredibly rare, and it's a very strong signal that A2A has some serious legs.
And this isn't just theory. Companies are already solving real business problems with this stuff. Tyson Foods is using it to get agents to collaborate on ridiculously complex supply chain logistics. S&P Global is standardizing their whole internal fleet of agents. And my personal favorite example is Twilio. They built an extension for latency-aware agent selection. That's a perfect use case of the extensibility model to solve a very specific, very practical engineering problem. Okay, so with that kind of foundation and momentum, where is all this headed? What does the world actually look like in 5 years if A2A becomes as ubiquitous as HTTP?
Well, the long-term vision is nothing short of an internet of agents, a future where countless specialized agents, owned by totally different companies and running on completely different platforms, can discover each other and collaborate autonomously to solve problems far too complex for any single system to handle. A2A is the infrastructure layer for that future. So I'll just leave you with this question to think about. What happens when this foundational layer is actually in place? When any agent can securely talk to any other agent? What new, truly cross-enterprise applications become possible? We're not just talking about smarter chatbots here. We're talking about autonomous systems that could manage global supply chains, financial markets, maybe even scientific research. That is the real promise of a standard like A2A. Thanks for joining this Explain.